This video will show you how to solve a first-order difference equation by using the method of Z transform. We are given a first-order difference equation y of k plus 1 minus 3 times y of k equal to negative 6, and we are given that y at 0 equal to 1. If we are going to solve this by Z transform, we are going to take the Z transform for every term in this equation. So this means I have the Z transform of y of k plus 1 minus 3 times the Z transform of y of k is equal to the Z transform of negative 6. Now let's look at the Z transform of each term. I'm going to look at Z transform of negative 6. We know that Z transform of negative 6 is equal to minus 6 times Z transform of 1. But 1 is the same as the unit step sequence UK, since UK is equal to 1 all the time. And the Z transform of unit step sequence is Z over Z minus 1. Therefore, putting this to the right hand side, I'll get Z transform of minus 6 is equal to minus 6Z over Z minus 1. Next, we are going to find out what is the Z transform of y of k plus 1. For this, you have to recall the first shift theorem. Recall that if Z transform of fk is equal to capital F of Z, the first shift theorem says Z transform of f of k plus 1 equal to Z times capital Fz minus Z times f of 0. That means this is Z transform of fk plus 1 is equal to Z times the Z transform of fk minus Z times f0. Now we apply this to our yk. So that means Z transform of yk plus 1 is equal to Z times the Z transform of yk minus Z times y at 0. However, we are given that y at 0 is equal to 1. So that means Z transform of yk plus 1 is equal to Z times the Z transform of yk minus Z. So Z transform of yk plus 1 is equal to Z times Z transform of yk minus Z. Now substitute this to our equation. We have the first term equal to, the first term is Z times Z transform of yk minus Z. Then the second term is minus 3 times Z transform of yk. Now you look at the left hand side, we find that there are common terms Z transform of yk, where we do not know what is the Z transform of yk. What we're going to do now is combine the Z transform of yk. So we have on the left hand side is equal to Z minus 3 times Z transform of YK, which we have grouped together. And on the right hand side, this will be minus 6Z over Z minus 1 plus Z. Now combine the right hand side. We have Z minus 3 times Z transform of YK. This is equal to minus 6Z plus Z times Z minus 1 over Z minus 1. This means Z minus 3 times Z transform of YK is equal to Z squared minus 7Z over Z minus 1. So, divide both sides by Z minus 3, I have Z transform of YK is equal to Z squared minus 7Z over Z minus 1 times Z minus 3. Now, we're going to find out what is YK, so we need to take the inverse Z transform. Now, before we take the inverse Z transform, let's factorize this and divide by Z first. What I mean is, consider Z transform of YK on the left hand side, which we're going to find. Now, the right hand side is equal to Z times Z minus 7 over Z minus 1 times Z minus 3. At the moment, we cannot do partial fraction because the fraction is improper. So what you do is divide both sides by Z first. So I have Z transpose of YK over Z. This will give me Z minus 7 over Z minus 1 times Z minus 3. Now, you apply the partial fraction. So I have Z transpose of YK over Z is equal to a fraction A over Z minus 1 plus B over Z minus 3. Now you can use the cover up to find A and B. So let's try to figure out what is A and B here. So cover up method. So A is on top of Z minus 1. So you cover up Z minus 1 in the expression. And then you put Z minus 1 equal to 0. Which means Z equal to 1. So A is 1 minus 7 over 1 minus 3 is minus 6 over minus 2 is 3. Now let's look at B as well. So B is on top of Z minus 3. So you copy the expression on the right hand side first, Z minus 7 over Z minus 1 times Z minus 3, and cover up Z minus 3. Put Z minus 3 equal to 0. This will give me Z equal to 3. That means B is 3 minus 7 over 3 minus 1, which is minus 4 over 2 is negative 2. So A equals 3, B equals negative 2. I'm going to put them back again. Now, multiply the Z to every term. Z transpose of YK is equal to 3Z over Z minus 1 minus 2Z over Z minus 3. Therefore, I know what is YK now. By using the inverse Z transform, YK is equal to 3 inverse Z transform of Z over Z minus 1 minus 2 times inverse Z transform of Z over Z minus 3. But we know inverse Z transform of Z over Z minus 1 is a unit step sequence UK, and inverse Z transform of Z over Z minus 3 is a sequence U power K. Therefore, the general expression for YK now is 3 times UK minus 2 times 3 power K. This will give you the general solution of the difference equation you need to solve. And this is the end of the recording.